So we have the highest point peaks, which are 0, 5, and the lowest ones, which are pi, -5. And the midpoint between 0 and -5 is what? I'm sorry, between 5 and -5.
0.
0, good. So our midline is y equals 0. And then our amplitude is the distance from the midline to the peaks. So what's the distance from 0 to 5?
5.
5, good. Okay, so that's how we're going to go through all of these instead of using, remember, before we had those equations. And for some of them, it might be useful if we end up with messy numbers, but I think we could do them all from the graph. So now we have to identify what transformations have been applied to either cosine of t or sine of t. So we have cosine of t here. So what transformation, and the same transformation rules apply as in the last chapter, what transformations were done to cosine of t? What happens when I multiply the output of a function by a whole number?
It stretches.
Yep, in which direction, horizontally or vertically?
Vertically.
Vertically. And it stretches by that factor. Factor 5. And we could see this if I go ahead and throw my cosine graph on here, we see that the green one is the original function, the parent function. We see that these peaks are just stretched by a factor 5. Any questions there? Okay, moving on to B. I will pop that graph up here. Okay, what is the period? So the amount of time it takes to complete a cycle. If I start here, I go all the way down to the bottom peak, back through the midpoint to the top peak, and back to the bottom peak, and the period length is 2 pi. Next, let's talk about our midline. The midline is the midpoint between the highest peak up here and the lowest peak down here, which the midpoint between 4 and -4 is 0. So y equals 0. And the amplitude is the distance from the midline to either the highest or the lowest peak, and it's going to be from 0 to 4. So the amplitude is 4. Any questions there? Okay, next then, how am I transforming this function?
It stretches vertically by factor 4 and it flips across the x-axis.
Good, yeah. So stretched vertically, it's not C. By factor 4 and flipped over x-axis. Okay, and so if I throw up the standard sine curve, which is the smaller one here, we see that it is in fact stretched by a factor 4. So the y value, vertically by a factor 4, the y value is multiplied by 4. So it would be, the peak would be up at, from here up 4, but then it's flipped over the y-axis. So that's why this sine curve, is starting at the origin and moving down instead of up first. Any questions there? Okay, moving on to C then. Clear my graphs. All right, C is y equals sine of 5t. So for C, we have to zoom in a little bit so we could see more what's going on. We start at the origin, and we have to determine the period. So how long does it take to complete a full cycle? And actually, let me maybe if I get rid of this, it'll be nicer numbers. Perhaps. Okay, so this period, I'm going to keep this as pi over 4, is a little messy because it's not directly on one of our points. Let's first talk about how is this function being transformed?
Is it being horizontally shrunk?
Yes, it's being compressed horizontally by factor 5. Does everyone see that? Remember that when we multiply the input by a value, if it's a whole number, it's being compressed. If it's a fraction, it's being stretched. It's opposite what happens with vertical. Does that make sense to everyone?
Yes.
Okay. So now to determine the period's going to be the hardest thing on this graph to determine. But does everyone see that the period is where I highlighted those 2 points on Desmos?
Yes.
Okay. So, well, the Desmos actually tells us that the period is 2 pi over 5. So we'll know that it's 2 pi over 5. But that makes sense because remember our sine, one period is 2 pi for our sine curve. Okay, one period is 2 pi for our sine curve. But if we're compressing it by a factor 5, I'm going to divide the period by 5 to condense it. And that's how we end up with 2 pi over 5. Okay, any questions on that?
If we didn't have like the Desmos, like how are we supposed to solve this?
So because in your textbook this says just to base it off the graph, I would say just go on Desmos. Desmos is just a website. So if I go here and I do desmos.com, once you go there, just click graphing calculator, and then you could type in your functions on the left-hand side. But if you did not have Desmos, you would go ahead and kind of go through that logic that I just explained, that we're compressing it horizontally by a factor 5. So our period is going to be divided by 5. So it'll be 2 pi divided by 5.
If it were being stretched horizontally by a factor of 5, would we multiply by 5 then?
Yep, exactly.
If we have a graphing calculator, can we use that, or would you prefer us to use Desmos?
You can use it. What's nice about Desmos is that I could change the axis. If I go to this little gear up here, I could change the axis from doing steps in 1, 2, 3, 4, 5 to this step in pi over 4. And pi over 4 gives you pretty much gives you the when it's exactly 2 pi or exactly pi or something. So it's a better axis to read in this case. Any other questions? Okay. So now let me get rid of this second graph so it's a little less messy. We'll zoom into about one period. So we know that our period is 2 pi over 5. What is the midline?
Y equals 0.
Good, y equals 0. And what's our amplitude?
1.
1, good. All right, any questions there? Okay. Problem D. Sorry guys, it's hard to write small enough for it all to fit on one paper when I have half the screen. Problem D, okay. This one looks like it might be better to get rid of this. Yeah. Okay. So we have to we can first determine the period. So how the amount of time it takes to complete a full cycle. So we have the period is 6 since this is cosine, I started at my peak. I really just try to, if it's kind of either the peak or the midline or the lowest point, I always, when I figure out my period based on the graph, I always start at x equals 0. As long as it's either the highest point, the midline, or the lowest point. All right. So from peak to peak, we have the period is 6. The amplitude in the midline. The midline, since our peak is at 1, our y value of our peak is at 1, and the y value of the lowest peak is at -1, our midline is y equals 0, and our amplitude is just 1. Any questions there?
What did you exactly type in the Desmos? Just so I have an example.
What did I type exactly? This is what I typed. So for this one, I have y equals cosine pi over 3 times x.
Oh, okay. So you just put in the whole entire thing.
Yep.
Okay.
Okay. So now looking at the graph or the equation of D up here, what am I doing, or how is my equation being transformed?
It's being stretched by a factor of pi over 3.
Yeah, so this one, since it's a fraction, there's a couple different things you could do, but I think the most straightforward thing to do is say that it's being, we'd say it's being compressed horizontally by a factor of pi and stretched horizontally by a factor of 3, right? Because we're multiplying by pi and dividing by 3. So we could just go ahead and actually split it up into two horizontal scales, if that makes sense to you guys. Any questions there? Okay, problem E. I'm gonna write it down here. E, y equals cosine of x plus 10. All right, so that's what we're dealing with, cosine of x plus 10. And I'm gonna switch back to my pi over 4 label. Pi divided by 4. Okay. So what is the period of this? I start here at the peak, and this is where I reach the peak again. What is my period?
2 pi.
2 pi, good. Next, we will determine my input in my midline, not my input. So the highest peak is, the y value of the highest peak is 11. Oops, let me get rid of that dot. There we go. Is 11, and the y value of the lowest peaks is 9. So what is the midline if those are our peak values?
Y equals 10.
Good. Y equals 10. And what is the amplitude here?
1.
1. Good. So the distance from the midline, which is at y equals 10, to either the highest or the lowest peak is either 1 down or 1 up. So our amplitude is 1. Good. Any questions there?
Can you just go over why the amplitude is 1 again? I'm sorry.
Yes. So our midline is at y equals 10. So it's right about where my dot is. And to get from the midline to the highest point, to the peak, so from here to here, we go from y equals 10 to y equals 11. So the amplitude is 1.
Oh, okay, thank you.
Yep. All right. What transformations are happening to this equation?
It's shifted up 10 units.
Good. And we can see that when shifted up, the midline is also shifted up. Any questions on that? This little note in teal is pretty much what we're going to be dealing with in the next section. So in the next section, we'll be dealing with determining the period, amplitude, and midline based on the equation without the graph. So that'll be the last section in chapter 8. So if you could start trying to make these connections now, it might be helpful. All right. Back up here, problem F. Okay. We need to determine the period, amplitude, midline, and then transformation. So we're starting here. And we'll go up, down, and then back to that midpoint here. I can't put a dot there. So what is the period?
2 pi.
2 pi, good. And then my midline what is the midline if my maximum, my max y value is -5 and my minimum y value is -7?
-6. Y equals -6.
Good. Y equals -6. Remember, it's a line. Good. So what if y equals -6 is my midline? What is the amplitude? So in other words, what is the distance from the midline to the highest peak?
1.
1. Good. Any questions on those 3 parts of this one? What is the transformations being applied to this function? What happens when we subtract from the output?
It's being shifted. Sorry, that was my cat.
That's okay.
It's being shifted down 6 units.
Good. Shifted down 6 units. Any questions on F?
Can you show E for one more second? Because I didn't get the
Yep.
transformation.
There you go.
Okay, thank you.
Any other questions? Okay, problem G. All right. This is another one where we're going to skip the period for now. If you guys want, we could do the amplitude and midline, but we have to do the transformation before the period. So what is the midline?
Y equals 0.
Good, y equals 0. And based off that, what is the amplitude?
1.
1. Good. Any questions on that? Okay. So looking at our graph, we have sine of 3/5t. What transformations are happening to the sine function?
Is it being compressed horizontally by a factor of 3 and then stretched horizontally by a factor of 5?
Good. Compressed horizontally by a factor of 3 and stretched horizontally by a factor of 5. Okay. So this is another one where, see how we're looking at this where on the graph where the period ends, right here, where the first period ends, we're looking here and we see that it's not really a nice number at all. I could just click on it and Desmos will show us the nice easy fraction. But before I do that, I want to just explain similarly to that other example. So before the transformation occurred, of course they're the same color. Can I change that? There we go. Purple. Okay. Before the transformation happened, the first period for the normal sine curve ends at 2 pi. This one ends right around here, right? Yeah, right around here. Oops, I didn't want to click it. But what's happening is we're compressing the original function, so the purple function, by a factor of 3. So that means that we're going to divide by 3, right? When we compress, we divide. So we have 2 pi divided by 3. So what happens here is we're taking the period 2 pi and dividing it by 3. But then we're stretching it horizontally by a factor of 5. So that when we stretch it, we multiply. So we have 5 times 2 pi over 3, which is equal to 10 pi over 3. So our period is 10 pi, over 3. Any questions on that? And if that, and you could always check it by, like I said, just clicking on the point in Desmos, and we see that it's 10 pi over 3. Any questions? Next, we have problem H. All right, problem H, we have to determine the period. So it starts at a
She
peak.
records the class. I just go back and watch it.
Oh, there you
It starts at the peak and we're going to end at another peak. So our period is again 2 pi. Next, we have the amplitude and the midline. Can someone tell me what our midline is if our highest peaks are at -4 and our lowest peaks are at -8?
Y equals -6.
Good. Right, so it's just the point in between would be -6. I'm like almost on it, but close enough. Okay. So if our midline is -6 and our highest peak is -4, what is the amplitude? And keep in mind that the amplitude will always be positive.
Two.
2. And lastly,
How did you get to?
because our midline is at -6, so to go from -6 to -4, we add 2.
Oh, okay.
Lastly, we have to determine our transformations. So we have 2 cosine of t minus 6. And to remember when there's kind of like that order of operations, right? So nothing is happening to the input. So then when we talk about stuff, transformations happening to the output, we have to start with the scaling and then we do the shifting. So what are my transformations happening in the proper order?
It's being stretched vertically by a factor of 2 and shifted down 6 units.
And shifted down 6 units. Okay. Notice that when this was stretched by a factor 2, our amplitude was multiplied by 2. And when it was shifted down 6 units, our midline shifted down, midline. Shifted down. Any questions on that? Moving on to problem I, which is y equals -3 sine of 2t. Okay, wow, this one looks aggressive. So we start at the origin, and one full period ends once we cross the x-axis again, because that's where the origin is on the x-axis. So what is my period?
Pi.
Pi, good. What is my midline?
Y equals 0.
Good. And my amplitude?
3.
3, good. Okay. So now we have to talk about what transformations are happening. Can someone tell me what transformations are happening to the input?
It's being compressed by a factor of 2 horizontally.
Yep. And notice that our period, that pi is equal to 2 pi divided by 2. And I'm getting this 2 from here. We also, what is happening to my output?
It's being stretched vertically by a factor of 3.
And lastly, we are flipping over the x-axis. Okay, when we stretched vertically by a factor 3, our amplitude was multiplied by 3. Our amplitude is 1 times 3 equals 3. Okay, so that's important to notice because typically our amplitude is 1 if it's just, if there's nothing there. And then flipped over the x-axis. So since we have a sine curve, we start at the origin and we flipped over the x-axis, so we went down first instead of going up. Any questions on I? Lastly, we have problem J, which is y equals 10 sine of pi over 2t plus 4. So our period, we cross the x-axis at the point 4. We go all the way to the peak, the lowest peak, and then we meet back at y equals 4 about here. And I think this one will be better if we look at it with 1. Come on. Come on. There we go. There we go. Okay. So if we look at our axis going up by 1 instead of 2 pi, we have 4 here. We go up to the peak, down to the bottom peak, and we get back to 4 right here, which is crossing where x equals 4. So our period is 4. Midline So what is the midpoint between our maximum of 14 and our minimum y value of -6? What is that midpoint?
Is it y equals 8?
Careful. So when we find the midpoint, we have, or the midline or the midpoint, y equals the maximum, which is 14 minus -6 divided by 2. And that's going to be 20 divided by 2, which equals 10. So our not 10. Whoops, this should be plus. Oh no. Yeah, plus. Plus 6. So 14 minus 6 is going to be 8, and 8 divided by 2 is 4. So our midline is y equals 4. Right, it's right here. And then the amplitude is the difference between 4 and 14 and 4 and -6. So what's the difference between 4 and 14?
10.
10. Good. So our amplitude is 10. And lastly, we have to determine what transformations are happening here. So according to our order of operations, we have to go ahead and do, I just realized it was 12:55. I am so sorry. So I'll just speed through this last one and stick around for questions. We have to go ahead and transfer that inside part, the input first. So we are compressing horizontally by a factor of pi, and we are stretching horizontally by factor 2, and then we are stretching vertically by factor 10 and shifting up 4 units. Any questions there?
Thank you.
You're welcome. I'm so sorry that I ran over.